The Electromagnetic Spectrum by Alan Pickett. The electromagnetic spectrum is all electromagnetic waves arranged by frequency. Electromagnetic waves on the electromagnetic spectrum have a wide variety of frequencies. Some waves vibrate once a second, and some vibrate trillions of times a second. Different portions of electromagnetic waves interact with matter differently, so they are named differently. A small portion of the electromagnetic spectrum is visible to humans. That portion is called visible light. Since we can't see all electromagnetic waves, many devices have been made to detect other frequencies, like radio antennas detect radio waves. Even though you can't see them, radio waves are all around you. Radio waves carry auditory messages, but you can't hear them. Radio waves are on the bottom of the electromagnetic spectrum because they have the longest wavelength and the lowest frequency. The wavelength of radio waves is longer than 1 millimeter. Radio waves can have many uses. One thing they are used for is radar. That stands for radio detecting and ranging. Radar uses radio waves to see how long it takes for the wave to bounce off the object and return to the receiving antenna. This is used to find the location and distance of an object. Law enforcement uses radar to measure the speed of vehicles, and the government and military use it to track the movement of aircraft, watercraft, and spacecraft. Radio waves are also used for magnetic resonance imaging, or MRI. This is a technique developed in the 1980s that can diagnose illness painlessly. It uses radio waves in a magnetic field within a large magnet and the protons in the bones and tissues to release radiant energy, which is received by a radio receiver, which is then used to make a map of the patient's body and tissues. Radio waves less than 30 centimeters are called microwaves. A subcategory of radio waves are microwaves. The wavelength of a microwave is between 1 and 20 centimeters. Microwaves are used in communication, such as cell phones and satellite signals. They are also used in microwave ovens. Microwave ovens use microwaves to create an electric field which rotates the charged water particles in food back and forth billions of times a second. This causes heavy friction, which generates thermal energy that cooks the food. Infrared waves have a wavelength of between 1 millimeter and 750 billionths of a meter. Thermal energy is transmitted through infrared waves, so basically everything emits infrared waves. The hotter an object is, the more infrared waves are emitted from it and the smaller the amplitude is. Without infrared waves, you wouldn't be able to feel the heat from a radiator or even the sun. Infrared waves are used in many day-to-day items. A remote control emits infrared waves to control your TV, a computer uses them to read CDs, and much more. Visible light is the range of electromagnetic waves we can detect with our eyes. The wavelength of visible light is around 750 billionths to 400 billionths of a meter. Our eyes have special substances that react differently to different frequencies, so you see different colors. All of the colors are arranged from lowest to highest in frequency, and the acronym ROY-G-BIV, which is red, orange, yellow, green, blue, indigo, and violet. This is also the order of colors on the rainbow. When you see all colors at once, it appears as white. Ultraviolet waves range from approximately 400 billionths to 10 billionths of a meter. UV waves are energetic enough to penetrate skin cells, which is good and bad. Most of the ultraviolet radiation that comes to Earth is longer wavelength UVA waves. Unfortunately, some UVB waves will reach the Earth's surface, and those are the types of waves that can cause sunburn. Even so, both UVA waves and UVB waves can cause skin damage, cancer, and wrinkling. UV rays would actually wipe out all life on Earth if we didn't have the ozone layer, which absorbs most of the sun's harmful ultraviolet waves. It's not all bad though. Some exposure to ultraviolet waves can enable your body to produce vitamin D, which is important for healthy bones and teeth. Some uses of ultraviolet waves is their ability to kill bacteria and make fluorescent materials glow, which is used by detectives to inspect crime scenes and show fingerprints. X-rays have the second shortest wavelengths at between about 10 billionths of a meter and 10 trillionths of a meter. This means they also have the second highest frequency in the electromagnetic spectrum. X-rays have a ton of energy. Dentists and doctors use X-rays to form images of bones, teeth, and internal organs. Since bones are denser than the surrounding tissues and organs, they absorb more X-rays, making them darker. This allows for there to be a shadow cast of the bones that need to be examined. X-rays are also used by the TSA to scan luggage at airports to examine the contents within. At the top of the spectrum, there are gamma rays. The electromagnetic waves that are smaller than 10 trillionths of a meter are gamma waves. Gamma waves have the smallest wavelength and the highest frequency of the spectrum. Gamma rays have extreme amounts of energy. They are powerful enough to penetrate through large blocks of lead. Gamma waves are produced in radioactive atoms where there is an alpha and beta decay. When an alpha or beta particle is released from the nucleus of an atom, a gamma ray is also released. This high energy producing method is used in nuclear power plants in a slightly different way. In these power plants, neutrons are launched into nucleuses, which causes tons of alpha and beta particles to fly away and produce dozens of gamma rays. Gamma rays and also X-rays are used in radiation therapy. This technique can kill disease cells in the body. The issue with this method is that it kills both healthy and unhealthy cells. Doctors combat this by using the perfect amount of radiation that will be just enough to kill the unhealthy cells and not damage the healthy cells too bad. And that is the electromagnetic spectrum, from radio waves to microwaves to infrared waves to visible light to ultraviolet waves to X-rays and finally to gamma rays.